Okay, hello. Good morning, good afternoon, good evening. Welcome everyone to the May 2021 monthly webinar series from Phase 1. Today's webinar is made together with our integration partner GGS from Germany, and we will get a tour of 20 years of history, GGS integrating Phase 1 technology. Let me introduce you today's presenter. My name is Carsten Wieser. I'm part of the Phase 1 sales team since more than 12 years and since quite some time acting as integrator sales manager. I'm based in Cologne in Germany. From GGS, I welcome Dr. Gerhard Kemper, who is founder and CEO of the company. GGS was founded in 1998, and today a team of around 12 people is specialized in integrating aerial survey equipment. Welcome, Gerhard.
Hello, Carsten. Thank you for the introduction.
So, yeah, before I hand over the presentation to Gerhard to let him give a short overview, I will give you a short overview about our corporate and products. Phase 1 is a world leading provider of digital medium format imaging solutions founded in 1993 in Denmark. We provide ultra high resolution cameras and highly productive software solutions. We operate several sales and support centers for Phase 1 across the globe. In Denver, Colorado, it is for the Americas region, in Cologne, in Germany, for EMEA region, in Australia, and in Hong Kong, we operate an office for Asia and South Pacific regions. Our company headquarters is based in Copenhagen, in Denmark, together with our main R&D center, and further R&D and production centers we operate in Israel and in Japan. In addition, we have more than 50 distribution partners, which offers a global network of sales and support centers, which makes us a fully customer-centric organization offering 24/7 customer support. Yeah, we really serve the world-leading brands with top image quality and productivity in various applications. Let me give you a short overview about our Phase 1 aerial products. So Phase 1 has been supplying specialized cameras for a while and a wide range of aerial photography applications starting in 2012. Those cameras are always made on the edge of technology by using the most modern CMOS or the most modern sensors available on the market, delivering the best possible image quality. Over the years, we have continuously developed these products to meet the market requirements. The journey started with the RXA camera, an 18 megapixel medium format camera based on CCD sensor technology. It continued with specialized designed lenses, as well as the first CMOS-based medium format camera in 2014. From that moment, the RXU camera family, with its smaller size and weight, together with many new features, grew our customer install base further. In the RXU series was then completed by the reliable industry unique RS shutter system and the 4-band kits. In 2017, we introduced the Phase 1 aerial systems, a full integrated turnkey solution. It contains also our first large format camera with 190 megapixel. In 2018, then a full new camera series was released, the IXM series. It delivered a complete new camera architecture with even higher capture rates and additional new features. Furthermore, the cameras are equipped with the latest CMOS BSI sensors. Phase 1 is the first company in the market introduced these new 150 megapixel sensors 2 years ahead of all other competitors. The IXM camera also brought a new possibility for UAV applications, and the IXM-RS is the new king of aerial digital medium format. Last year, we announced the PRS-280, a large format aerial system with 280 megapixel and more than 20,000 pixel cross-track resolution. A further addition to the PS system is the release of our new flagship model, the PS-880, which was just announced end of 2020. It is the first Phase 1 large format and oblique camera system with 280 megapixel nadir view and 4 times 150 megapixel of oblique view. The cameras of the IXM series can be easily integrated and used in a wide variety of aircraft. Due to its size and weight, the IXM is ideal for all unmanned drones or anywhere where size and weight matters. The cameras of the IXM-RS series with their even higher resolution are part of our Phase 1 aerial system, but also are built into a wide variety of aerial imaging systems. made by many other integrators around the world. These cameras are also often part of airborne LiDAR systems and helicopter-based systems for optical inspections. The XM series cameras are often used in drones and inspection applications, such as inspection of bridges and roads, pipelines, railway, wind turbines, power lines, in agriculture and phenotyping applications, as well as in mapping applications that require highest level of accuracy. The XMRS models are mostly used on larger areas in manned aircrafts, also for mappings, application in agriculture and forestry, as well as environmental monitoring for these 3D city models and next to airborne LiDAR systems, and also for inspection. Yeah, but now it's time to hand over the presentation to Gerhard Kemper from GGS. Let's see various examples how GGS uses phase 1 technology in the last 20 years and today. So thank you, Gerhard, for joining. And yeah, so please continue.
Thank you, Carsten, and also welcome everybody around the world visiting us. So just checking if it's moving forward. Okay, that's my short agenda for today. A short introduction to our company. So we are this year already 32 years on the market, and yeah, what we deliver is all-in-one solutions. We have meanwhile 50 employees. And we do a lot of things in integrating cameras, different sensors, stabilizers, flight management system, and we provide ready-to-use complete systems. Just today we had our second following audit from the TÜV Süd, and we are ISO 9001 certificated company. So we have a quality management system in-house, and that allows us to deal also with big partners like Siemens and others. Our location, our headquarter is in Speyer in the western part of Germany. We will move over our R&D and headquarter in Q3 to Wissembourg in France. So we have a better place, more environmental possibilities to enlarge our workshop and everything. We have opened our branch in Turkey, in the Volcar Towers in Izmir, and we are going to do also something a little bit like a developing strategy as a UAS competence center in Namibia, and we are looking there with partners to get some training and give the people there something on hands to do their own business. We have partners all around the world who are our resellers, and we have many partners who deal with us with their sensors and their integration partners, components for the turnkey solutions. I will jump a bit into history, how we came to this job. So we started in 1988 with meteorological sensors and equipment for soil geology and others. And we did already that time with typical theodolites, the first digital terrain models. It was the time when just the first ideas of GIS came up, and photogrammetry was still on, let's say, more manual digital plotters. And some years later, in 1997, we started with the first differential GPS systems and reached already 2-meter accuracy and used that for GIS data combination. And of course, everything was correct at that time because normal GPS was about 100-meter inaccurate. We followed up with the first combination of GPS and different sensors, for example, echo sounder, pH value measurement and conductivity. And we measured, for example, lakes for the water quality and created already the first 3D sub-sea level terrain models. We jumped already 2001 with our handheld GPS and already the first maps that have been GIS and GPS supported for Powerline Monitoring. It was still manual, so it was, let's say, looking for isolators for damages visually and put that into the Geo database. 2002, we used already GPS, but still with analog cameras. We used there, for example, here the Rolleimetric camera with réseau plates for measuring in photogrammetric methods, and we used already color infrared, RGB systems, and everything was already controlled by GPS that time, so it was the first attempt of flight management system. We already did something on UAV technology because we wanted to create high-resolution digital data. That time we used balloons as a photogrammetric carrier, and we had here already a stabilized digital camera with 4 megapixels, remote control, and that's the terrain model with the modern software which was created out of this model. That was the theater in Patara in Turkey. We did something similar already with a phase 1 digital bag on a rollermetric camera in 2003. It was also a balloon mission over the Acropolis in Athens. That time there were no drones, what we know up to today. And here we used already GNSS and Bluetooth communication, but it was still, let's say, fixed balloon with 2 ropes, and we reached GSD of 5 millimeters that time. And in 2004, F5, we started with the first stabilizer, still, let's say, a bit handcraft workshop with a rollermetric phase 1 camera with 22 megapixel. It was really the best that time what was available. And we used that in a Zeppelin, a remote controlled in China. And we got the first, let's say, aerial mid-format results in these days. It led up in 2005 to improve the stabilizer, the communication, and use also gyro sensors for the stabilization and direct referencing. And it led that we've flown with the first ultralight aircraft in China that time. And 2008, we used already the first combination of mid-format camera with a P25 digital bag and modified Nikons for red edge detection. It was a 5-band solution, and it resulted, of course, in some debayering of the near-infrared canals and results in a red edge detection mapping of test site in Switzerland to generate, let's say, the right fertilizers and some sickness of plants and these things. Error integration, so the first turnkey solution we sold was again to China, used in a trike. It was already our first or second model of stabilizers with a rollermetric with a P45 39 megapixel digital bag, and was mounted in the trike. And we've flown the first mission successfully, and the system increased and was a long time operational also for measuring or detecting the damages of the Sichuan earthquake that time. 2009, we used the first dual camera setup for wide area mapping with 2 rollermetric P45 cameras mounted under a certain angle with a certain overlap and stitching software, and it was mounted in the surveying aircraft of the IJN of Panama. And we performed a calibration flight very close to the Panama Canal. 2012, we are already in the phase 1 history of the young phase 1 developments. It was the first digital complete photogrammetric camera, the IXA 180, and we already combined there 3 cameras of that for a wide area mapping in Sudan with the 3 cameras, and we already had the synthetic frame of 26,800 pixels cross, and it was mounted on our stabilizer aerostat twin with a Novatel span, GNSS, INS, and our flight management system. And we created 30 centimeter GSD true orthophotos of the Nile area. 2014, we had the installation for the DAISY, a seabird monitoring system. The request was high resolution to detect the types and numbers of seabirds, and the system operated well with many images, also detecting other animals, and we had 1.5 centimeters GSD already in this times, and the system already is now upgraded to the latest phase 1 technology with longer focal lenses. 2015, we installed our first Oblique system with 4 IXU50 and the IXU1000 as a Nadia camera for Linkfast in Taiwan. And 2016, we used the 4-band system installed at the aircraft of the Aerial Surveys Limited company. And we did the first missions with this system. And in 2018, we installed our Oblique imaging system L with a 4-band system and did a calibration in Speyer that results in 2 flight altitudes, cross-flight, tie point matching, adjustment in bingo, and getting for each camera the calibration parameters and reduce the distortion with additional parameters. So that is something what we typically do when we deliver a system ready directly to start with missions, that is ready, calibrated using bingo for, let's say, the best possible results. 2019, we installed the 8-camera system for open skies in Romania, and it's designed to fly at 3 different altitudes to get a maximum resolution of 30 centimeters. And for each flight level, we have a 4-band solution. That's the nice aircraft. And I would be happy to have more such aircrafts to install the technology, because we have a lot of space and more comfortable to fly. But in many cases, it's relatively small aircraft, just enough to get the system nicely mounted. Yeah, the system, of course, in Romania is a quite complex one with many monitors for the observers and the controllers and the different camera setups to get them set up differently. So you see the systems get quite complex at time. What components do we use today and which components do we integrate? Of course, there are the different phase 1 cameras, the 280, 150 and 100 megapixel camera with the different lenses that we are integrating. We are using different thermal cameras, some of them with industrial standard, some of them steering cooled for very high resolution and fast capture rates. We use ultraviolet cameras from different brands, in the meantime more from Proxyvision with amplified detection and daylight filters. And they are typically used for corona discharges on power lines. And we combine them, for example, with RGB cameras and also thermal cameras. We integrate the different Regal scanners. We did a lot in the last 2 years on that basis. And of course, the integration is done also with hyperspectral sensors for different applications, 5-band and multi-band solutions. We have our stabilizing platforms, our small one for single camera solution, the Aerostep M that can carry, for example, a 280 plus near infrared sensor, or the Aerostep XL that is the biggest, let's say, on the market with 42 centimeters hole that is able to carry also big oblique systems. And of course, we have all the range of GNSS and INS systems to integrate them. Our Aerodidos, our direct integration and registration system. We are using components from Novatel and Aplanix, and we have them from, let's say, low grade to ultra high grade, depending on the request. Our mission planning software develops more and more. We do a lot of things on the Powerline monitoring and have developed also specific tools for this one. And we have also the navigation part as a flight management system that's guiding the pilot through all the missions with a moving map and also instruments and collecting the data from each snapshot. We do things, of course, with a phase 1 4-band solution, and we integrate also 5-band solution for detecting the near infrared. You can see in the sample the RGB, the near infrared, and the NDVI resolution. We did missions in different altitudes to check the systems, to detect if we get the right speed if we capture everything in a certain quality, zooming into some parts, we also can, if there's clear water, to look also deeper into the environment and detecting also the breed places of mosquitoes close to the Rhine here. The combination of RGB and thermal infrared seems to be a bit unlogic, but it makes a lot of sense when you see also in daylight conditions the thermal radiation, because it indicates where you have good areas for solar energy. It also indicates where you have certain environmental issues. And we combine it, of course, with our flight management system, because the thermal camera needs some special dealing with recalibration and so on. We have integrated an interface for that. And that's a combined result, for example, the thermal image overlaid over an orthophoto, and you can see the urban green very, very extreme as a cooling effect, and you can see the south exponated roofs in the aspect that shows you also the different, let's say, thermal radiation and effects of urban climate. Oblique imaging system, it's also one of our big components. We have a certain range of small, medium, large, and 4-band systems. And I shortly will present our latest baby, which contains a 280 megapixel Nadia camera from phase 1, 450 megapixel camera as Oblique, plus thermal cameras for the urban heat detection. That's like how the system is looking like. So you can see here the 280 megapixel camera, the near infrared Nadia camera, the Oblique cameras, and the thermal cameras that capture, of course, in a far less accuracy and resolution, but detects, of course, the urban heat effects. These are the footprints of the different sensors, calculated now for 5 centimeter GSD. And that's the range of GSD that's affected by the oblique view. But I don't want to go too far into the details. And what you are able to capture are data of 3 centimeter GSD, depending on the speed of the cameras. Yeah, you can reach also 2 centimeters, but with 1 centimeter, of course, depending on the flight speed, there are limits on the capture rate. Some examples of photos, what we have in 2 centimeter GSD. And that's definitely impressing what you can detect here. And that's also one effect where you can see very good, finally, on the thermal images, if these solar panels are operating in a health status or if there's a repair should be done. This is a 3D model on the left-hand side. I'm just going back. So it's not an image, it's really a 3D city model of the city of Speyer, which we use typically for calibrating the system. We have over 100 control points in this area. And for 3D city models, it's a very nice test site. That's a nice test site. I will show later a short presentation of this area of Wieser in France. Also a 3D model, which we captured with our oblique imaging system. And we did also with our drone on this part. Multi-sensor integration, it can be also a deeper integration. That's what we typically do on the Powerline Monitoring system, what we did with Siemens. We've integrated their 500 megapixel cameras to capture with a 2 millimeter GSD, the power line and the infrastructure. We have LiDAR that collects 250 points per square meter, 3 thermal cameras, a corona camera, direct referencing, and in that example, we have also exacta electromagnetic detector. That's a digital twin calculated out of the data, LiDAR and aerial images. And what you see is a very detailed resolution that enables also AI technology to detect automatically some failures, some issues, some findings on the power line. How looks such a system? Of course, you have a flight management system that especially has tools for snake line flights to follow the line without entering separately. You have the GNSS INS as the central heart of it. We have the camera setup in a daisy chain. We have the thermal cameras that are synchronized. They have our own, let's say, controller unit. We have a corona camera that captures images with a 50 Hertz frame rate combined with the RGB camera. We have, of course, a LiDAR system and, of course, a central storage and a control monitor for the operator. That's the sensor head that we have developed for Siemens, which is actually today in Schleswig-Holstein in operation. We also did integrations, payload integrations for Swiss drones, for example, here with 3 RGB and thermal cameras to capture data in a very high resolution on a test site here in Switzerland. We also have, since 2 years, our own UAV development. We have 2 UAVs, the Aerospectre and the Aerospectre S, for different payloads. The Aerospectre is our bigger baby. Actually, it's designed mainly to carry, let's say, several sensors, for example, a Regal, Vuxus, and a high-resolution camera, or gimbal for stabilizing, or as a smart gimbal solution, and of course for the wide area mapping, inspection, monitoring, and surveillance applications. That's one test mission we did with the system 2 years ago. You can see the drone, even it's a quite big baby over a power line in 100 meters, it looks relatively small. That's why it's marked here. And we capture here a power line pole. And you see here on the image already marked some findings on the isolators. And that's the laser model generated with a Vuxus. Smart gimbal solution, that's also a new development where we are still working on it. So we have at the moment 2 gimbals under construction, a small one for a single camera, you see on the left side down here. That's our small gimbal, and that's our bigger gimbal, 3-axis. And what is a smart gimbal? I would like to shortly explain it here. So it's a system that not only balances the sensors for roll, pitch, and heading movement, it's also active. It means it's checking for points of interest. You can see when you are flying by that the system rotates to the point of interest and focus the next one. That's important for flat terrain, but more even on a hilly terrain where it can follow the terrain while, for example, a helicopter UAV is climbing and descending and still has the object into the focus and into the view. We already have made some integration of different images captured by aerial systems, for example, our Oblique imaging system, and the combination with the UAV data. And I want to show shortly something on this picture. You can see here the UAV images captured, and here an example that's the result of the Oblique imaging system with 5 centimeter resolution, and here 5 millimeter UAV data, and we can combine them into one model. And I think I should share my screen now.
So yeah, our presenter. Yep.
So is it possible to see my screen?
Yes. Mm-hmm.
Okay.
I see it.
Okay, so that's a 3D city model of Wissembourg. And I want to show you here that's the Palais Stanislas. It's under reconstruction. And you see here, it's already a very nice, let's say, 3D model of the roof. But when you zoom in, the quality gets bad. And when I switch to the UAV captured data, which is now a model inside the wider model, you can zoom in and you see here a lot of small details, and especially for such kind of objects, when you want to have more resolution for cultural heritage, it's a very nice, let's say, combination of this kind of data. You don't need that, of course, for a whole city. That would be a data volume which is not possible to handle, but I think for this specific objects, you see far more details, and it can be used, of course, for all this archaeological and conservation purposes. Okay, Carsten, you can take over again.
Okay. Okay, so we're back to the presentation. Yeah.
So, okay, I'm moving forward. It's not moving.
Okay, try once more. Yeah.
Okay. Yeah, I'm already at the outlook and new developments. We are working on newer, faster, and more integrated mapping sensors, for example, also on the Oblique imaging system. We are already in the process to optimize the workflow. It means from planning, data capturing to the processing, so that the things are more smooth, more integrated. And yeah, the idea is to have everything, let's say, in one environment, that you don't have to deal with different data sources, and just, let's say, plan, fly, and have every data together for the processing, for example, in Skyline software. We develop new tools for mission planning and navigation, especially for power lines. We already did a lot of that in the past. We are using new PTP sensors. It's precise time protocol to integrate and synchronize sensors to GNSS time. So we have a lot of experience meanwhile in this data combination and to get the camera synchronized. And that was always in the past, because many of these industrial cameras work like a video stream, and it's hard to synchronize them. And we found out that with PTP, we get everything on the same GNSS time as the other sensors like LiDAR and the phase 1 cameras as well. We have also reached a good value in real-time overlaying and error detection in the UV band. And we develop a wider range of smart gimbals also for other UAVs and helicopters. We are also thinking on tools to use autonomous UAV missions to combine them with 5G technology. We are entering a project for Firebird, that a drone itself can try to detect a fire nest and automatically try to find and fly close to this area and give the information with a video stream to a central, let's say, disaster server. And we do also implementations to control UAV swarms with different sensors, with collision sensors, and we are working on that field in the future as well. That's everything from my side at the moment. So
okay,
I'm happy to wait
Gerhard.
for questions.
Yeah, so as always, after a webinar, we have some time free for questions from the audience. So I will now welcome Tina, my colleague. She will hopefully have some questions collected.
Yes, thanks, Carsten. We do have several questions from the audience. And I think we're just going to start with the first one, which is looking at the Open Sky system for Romania. And the question is whether it's a commercially available system that can be purchased as a turnkey system.
So
okay,
I hope you could hear the question.
I couldn't understand, but it's a very strange sound. So you should switch off your robot. Yes, the system from Romania is actually commercially available. So there are no components which are, let's say, stripped, but I hear myself also some strange voice. I don't know, can you hear me?
Yes.
Yes.
Tina, your audio is quite bad, sadly.
Yeah, just changing some settings.
Can you mute and unmute once more? Maybe it helps.
Okay, so I can hear me now better.
Is that better?
No, same. Yeah, maybe keep it muted for the moment. I will answer. So the system from Open Skies, it's more or less a commercial system. Of course, it's customized for this specific purpose, but there is nothing, let's say, hidden or forbidden or very secret parts which can't be shared to others. So it's definitely an open and commercially available system.
Okay, thank you. Tina, can you try once more? Hopefully we can hear you.
Yeah. Yes. The next question, I think I actually have two questions going into the same direction, so we can just look at them both at the same time. It's about nice pictures and resolution with great precision, but it's also creating a lot of data, so it's more like a big data project. So the question is like how to handle these amounts of data.
Now I'm not sure if I've understood right. So I think it's a question about high resolution in combination with, let's say, more core resolution data. Yeah, I think that's definitely what I tried to show on this small 3D model of Wieser, that let's say you can capture something in the core resolution and then focus on specific object where you definitely need this high resolution. And I think that's definitely something for the future, because we will not be able to handle such amount of data, and it also makes no sense to have everything, let's say, in ultra high resolution.
Okay. Yeah, I'm very sorry for this noise a bit. There's some technical problem we need to investigate. So I hope the answer was found well from Gerhard, and yeah, we try it once more. Tina, do you have one further question?
Yeah, try to change some settings here, so hopefully that's working better now. The next question is like combining close-range UAV with remote sensing aero data. Is that something that's coming up in the future?
I'm sure that it will come up in the future, because we have learned that there are, let's say, to combine this data, there are many UAV data which are, let's say, isolated in the environment. So it's just a single object and you can't see them, let's say, in the wider context. Besides that, especially this high resolution UAV data, they help for many applications in 3D city models, for example, also for tourist guidance, where they want to see on beforehand, let's say, these objects in details, and it also helps in the example of the Palais Stanislas, also in the conservation and documentation process. So I think that's something which comes up more and more, especially because the UAV technology has improved so fast, and to deal with the data, it's far more easy than, let's say, 5-6 years ago. So I think that's definitely something that pops up.
Okay, thank you, Gerhard. So I just opened the question chat box myself, so I take over and will ask the questions now. So I have one question received here. The drone you have used to fly over urban areas, which was it? Yeah.
It was in that case the Aerospectre S, our smaller one, with a single camera.
Okay. Then I have another questions. The solution you delivered 2006 to China, if it's still in operation, somebody asks.
Yeah, they just have, let's say, changed the camera from 39 megapixels some years ago to the 100 megapixel camera, but the flight management system, the stabilizer, without any repairs or inspection, it's still operational. It's still in the air.
Okay. And then I have a more specific question. This is related to the Corona camera. Yeah. When the camera is collecting images with 50 frames per second, you mentioned how you handle this huge amount of data.
Yeah, that's definitely a challenge. So we have two of them. So we have the ultraviolet camera and the RGB camera, roughly about 1.2 megapixels each. And that's of course a data stream, which is just enough to handle it, to get it dealt. And what we are doing is on the fly, we overlay them, because the ultraviolet camera just collects, let's say, black and white. It just collects single corona and photon blobs. And so we superimpose them on one image. And at the moment, we are working on the step that we analyze the data. If there is, let's say, some finding, if there is something on the ultraviolet band. If not, we will delete, let's say, more than 60–80% of the images, just to store some images with some findings. And if we have findings, we of course collect the full frame rate, as long as we have findings on the ultraviolet band. So that reduces, of course, the data which we finally have to process. And we get on the fly indicator that there is a finding, and the operator can view, okay, this isolator creates some corona effect. That's a nice thing. That's a big step we did this year.
Okay. Then I have another question. As you showed the example of the Oblique data set, which was collected with 5 centimeter GSD, and you showed the example for combined UAV data, which you put into this data set. Do you see this as a common new application for the future? And can you name further applications where this is from use?
Yeah, I see, especially for 3D city models. I think I mentioned it already, a big demand on that, because some objects you want to have in this ultra high resolution, also for, let's say, touristic applications, for checking for, let's say, repairs that have to be done. We did it also in Wissembourg for some other facade, which is, or other roof, which is actually under reconstruction. And it also helps to, let's say, document all reconstruction steps, and you want to see all this data in a wider environment. That can be done also with, let's say, wind turbines when you have this data, or you can use this data also as a sample for modeling, let's say, new wind farms, how they influence the landscape. I think this combination is a very interesting one, because the advantage of a UAV is that you can collect data in a very high resolution, and the disadvantage of UAV is that you cannot cover, let's say, bigger area. That's definitely, let's say, the combination of both aerial survey and this type of data is I think, the future.
Okay, thank you. I think these were all questions so far, but if there are coming further questions in your mind later on, so you see the email addresses from myself and from Dr. Gerhard Kemper here on the screen. So feel free to drop an email if you have further questions. Let me see if there's further arrived. No. So yeah, then thanks very much for all your information, Gerhard, you shared with us.
Thank you.
Yeah, hope to see you sometime again. And so for today, I would now close the webinar. So yeah, thank you all to all viewers, and also especially for Gerhard for sharing all his informations. Thank you for joining this webinar. Looking forward to see you again at the next webinar. Like always, the webinar is recorded and will be provided here within the next 2 or 3 days on our website. So you can go back and view it again or reference it to someone you know that also would like to see that. Yeah, so thanks again.
Okay, thank you very much, Carsten, and thanks for the audience and the questions, and I'm happy to answer other questions popping up by email. Thank you very much.
Good, thank you. Thanks to all, and have yourself a wonderful and great day. Thanks a lot.
Okay, bye-bye.
Bye-bye.